Hello ladies and gentlemen. So what we're going to do now is take a look at 5.7, finishing off what we had for our sine function, our sine curve. So we're making connections, and how can you model a periodic phenomenon such as the number of daylight hours in a year or the volume of air in your lungs as you breathe? Accurate models of periodic behavior in real world typically involve combinations of transformations of the sine curve. So a real life example of this is you're watching a video or something, and they're in the hospital and they got the heart monitor, and the little heart monitor going beep 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 beep, or blood pressure or whatever that is, and we could look at this and we can normally try to model this. We can come up with a mathematical model that'll simulate this pattern using the sine curve. So a Ferris wheel. We're going to talk about a Ferris wheel, and the Ferris wheel is going to turn and it's going to model a sine curve. What's going to happen is we're going to have a Ferris wheel like this, and we're going to get on the Ferris wheel and it's going to turn, and then our Ferris wheel is going to take us up to there, then our Ferris wheel will take us to there, then our Ferris wheel will take us to there, and it's going to keep going around and around and around, and that's a Ferris wheel. And what we're going to be doing is we're going to be marking the height of our rider above the ground. So there's going to be the height above the ground that we get on the Ferris wheel, and then that height's going to go up, and then it's going to go even higher to a maximum, and then it's going to come down, and then it's going to be at the lowest point again. So you're going to see your Ferris wheel, the height above the ground is going to start at a lower point, so at time equals 0 before we start turning when we get on, and then we're going to slowly go up. We're going to hit a max, and then we're going to slowly come down to that minimum again, and then it's going to go around again, and you're going to come down, and you're going to see we're going to get this type of motion. And we're going to be able to fit a sine curve to it that's going to be moved around a little bit, and that's what we're going to do. We're going to find an A value and an H value and a K value, and we're going to be able to take this idea of this person on the Ferris wheel going around, 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 and their height above the ground changing as time progresses. So it's height above the ground as time progresses. So as a Ferris wheel turns, the height, h of x, in meters that a rider is above the ground is given by this equation. So someone's already done the work for us. They've calculated out the equation for us. I'm going to focus in a little bit. And that's the equation. Sketch the graph in the space provided. Okay, well, notice here, I got an amplitude of 6. So I talked to you guys a little bit about how I would do a question like that. And to do this question, I would really take a look at it in separate parts. I would stop and say to myself, okay, I've got a vertical stretch of 6. So it's going to have an amplitude of 6. What else do we have? We have a phase shift of 90 degrees to the right, and you got a vertical shift of 8 units up. And what I would do is I'd start with this one, because your stretches have to come before anything else, and we've talked about that. So this has to come first, and then I'm going to move it around this way. So I'm going to have 2 different colors going on here. So I'm going to sketch this one first. Now this first one, if I'm just doing an amplitude of 6 or a vertical stretch of 6, the curve that I'm graphing is this one. Now, we know that something interesting happens with this curve every 90 degrees. Now, in terms of 90 degrees, yeah, we're going to do that. So it's 30, 60, 90, 30, 60, 90, 30, 60, 90. I don't know why I'm counting that way. 270, 360, and then I guess it would be another 90, which would be 450, and then another 90, which would be 540, and then another 90, which would be 630. Okay, so, and we're going to go up to at least 6. 1, 2, 3, 4, 5, 6. But if I do that, there's no room for my vertical shift. So let's go up by 2. So we'll make this 2, 4, 6. -2, -4, -6, and then we'll have 6, 8, 10, 12, 14, 16. All right, so let's see what's going on here. It's got an amplitude of 6. So the first one that I'm going to graph is going to look like this. It's going to go here, 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 and here. And that's just because that's what I know, right? That's how the sine curve goes if you have a vertical stretch of 6. It goes up to 6 and it goes down to -6. Now, let's do our phase shift. It's 90 degrees to the right, so this guy moves to there. And it's 8 up, so instead of being at 0, I'm going to go up to 8. This guy is going to be 90 over, and it's going to be 8 up from 6. Well, that's going to be 12. So that goes to here. This guy moves 90 over, and it's going to be up 8. So it's going to go to here. This guy's going to be 90 over, and it's going to go up 8. So it goes up to here. And then this one's going to be 90 over, and it's going to go up 8. So it's going to go here. So the whole thing has been shifted up 8, which means that this horizontal axis has actually been shifted up 8. So what I like to do is take that axis and move it up to where it goes, and it allows me to see what's happening a lot better. So that's my horizontal axis now. Everything's been moved up 8, and here's my curve. It's going to go like that, going to go like that, going to go like that, and it's going to go like that. And that's just a beautiful thing. So let's see if it makes sense. My lowest point here is going to be 360. Oh, what happens if I come this way? So if I continue the curve, it'll come down to here. And that kind of makes sense. Let's go back to my diagram that I have. So that means that this height here will be 2 meters off the ground, right? That's the lowest part. And then it's going to go up to 8 meters. So this is going to be 8 meters off the ground. Then it goes up to a highest mark, which is going to be 12 meters off the ground. And then it's going to come back down to 8 meters. It's going to be the same height. Oh, and it's going to be the same height on either side. So let's see that again. Starting at, let's see here. Starting at 2 meters at time 0, so before the ride starts, goes up to 8, goes all the way up to 12, comes back down to 8, comes back down to 2, and then it's going to go back up to 8 as it starts its circle again. So it's going around and around and around. That's kind of cool. So explain why the sine function is used to model the rider's height. You know what? That's a dumb question. Why is the sine function? Because it fits the curve. Because it works is really the right answer. If it didn't work, we wouldn't use it. We'd use a different equation. Why does it work? Well, because it's periodic. And it's nice and smooth. And also, when you think about the function, it's going to go up to a max, a nice down to a minimum, back. But that goes back to because it works. And so that's just a dumb question. What's the initial height of the rider? Well, if the initial height is when time equals 0, before anything happens. So if I look on the graph, I'm going to tell that it's 2. So it's 2 meters. I can tell by the graph. I could use the equation. So it's going to be, that's the equation. And if I want to know the height when time equals 2, so what we're really doing is when x equals 2. Now I use t here, but we're finding out when x equals, when x equals 0, right? The initial height. So x is going to be equal to 0 here. So what's going to happen is I'm going to get 6 sine 0 minus 90 plus 8. So this is 6 sine negative 90 plus 8. Now, if you're not too sure about that, we can use our calculators. Just make sure that you use it properly. You're going to do 90 negative sine. And the answer is -1. -1 times 6 is -6. And it's going to give you an answer of 2. And that's what we got from looking at the graph. And we also get it by plugging into the equation. Now, if that bothers you a little bit about why sine of -90 is going to be -1, let's think for a minute about how it works. It's 90, 180, 270, 360. So you know that the sine curve goes like this. That shouldn't be confusing to anyone, but we should also know that it comes out this way. So sine of negative 90 is going to be negative 1, which is sine of negative 90 gives us that negative 1 value. What is the height of the rider after 300 degrees? Well, we can look at it on the curve. That's 270. This is going to be 300. So it's going to be approximately somewhere between 5 and 6. So I'd say 5.5, approximately 5.5 meters off the ground. Now, if that's not good enough for us, and I don't know why it should be, we can also look at the equation. So we can say, okay, so remember the equation is 6 sine x minus 90 plus 8. So in this case, we're going to let x equal the 300, right? We're going to plug that in there, just like we did above when we put in 0 for the initial height. So height of 300 is going to be 6 sine 300 minus 90 plus 8. So it's 6 sine, now 300 minus 90 is 210. 210 degrees plus 8. So using your calculator, you got to do it in the right order. We're going to do sine of 210, and then times that by 6, and then add that to 8, and we find out that it's going to be it's exactly 5 meters. So my graph's off a little bit, or I estimated up way too much. There's 6 and there's 5, but it wasn't too bad. You know, not bad. Certainly this is the more accurate run. This is just interpolation using our graph. And what's the maximum height of the rider? Well, again, I can go and look at this and I can tell you my maximum height's going to be 12. There's a couple ways of seeing that from the equation. If you think about the equation, now once again, here's the equation for his height. So if we think about this equation a little bit, we see that we have a vertical stretch of the original function. That means it's a vertical stretch by a multiple of 6, so its maximum height, instead of going up to 1, is going to go up to 6 plus 8. So that's going to be 6 plus 8 is going to be your 6 plus 8, it should be 14, isn't it? 6 plus 8 is 14. Did I do something wrong in my graph? 6 plus 8 is 14, most definitely. Come over here. This one was supposed to, let's see, move over 90, and it should have gone, this one, moved over 90, and it should have gone up 8. This is too short. This should have gone to 14. There's a mistake in my graph. Isn't that interesting? So it comes up here to 0, 14. So I missed that when I did this. My maximum height is 14. And I found it by going through the equation. I'm not going to redo a new video on this because I think this is really neat that I was able to use the math to find my mistake, that this needs to be 14, and I went too quickly when I took this point and I moved over 90 and I moved up 6, or moved up 8. That was my mistake. I moved up 6. So I moved over 90 and I had to move up 8. 2, 4, 6, 8. And I should have gone to 180, 14. All right, make that correction. And stop the video there and we'll do the next side of this page.